And so then we keep looking at more and more information. One of the other pieces of information we looked at is looking at the age of the rocks. So we send down oil rigs, and then the oil rigs go in, and they start bringing up these rock cores, these core samples. And one thing that they notice is that the rocks are actually getting older the farther you move away from the ridge. So we go back to this page. As you move away from the ridge, you're getting older. So you get older rocks away from the ridge, which that's kind of interesting because they shouldn't be getting older. If the ocean floor is unchanging, then we shouldn't have younger and older rocks. They should all be the same age. In fact, the oldest.
Hi.
Hi.
We need this ran out for the blood drive.
Not doing
Is everybody having
it. Yeah, I'm not doing
it? You're not doing it? Okay.
So what we found out is that our oldest rocks are actually 180 million years. Again, guys, put that in perspective. How old is the Earth? 4.5 billion. By the way, what was our oldest rocks that were found? About 3.5 billion, 3.8 billion years ago. And that's on the continents. So remember, if we go back to the original part of our notes, we said the ocean crust is older than continental. And what we just found out by taking those core samples from the oceans is that the oceans are actually much younger than the continental crust. Way younger. So our ocean crust is younger. The oldest is only 180 million years old. And it gets older as you move away from the ocean ridges. That's a big concept. Now, the other thing is the thickness of the sediments. So as you move away from the ridge, the thickness of the sediments gets thicker. So at the ridges, it's only a few hundred meters compared to several kilometers. Okay, so there's a big difference there in the thickness of the sediments. You can see this in your textbook on page 450. Which you can also kind of see right here in this diagram, where we have relatively thin versus thick sediments. Again, so the farther you move away from that ridge, the thicker it is. Now, I'm going to ask you to put this all together. I presented you with a lot of information, a lot of scientific data. I want you to take 2 minutes. I want you to talk to your partner. I want you guys to actually discuss this. What does this mean? Remember, we're not quite ready for plate tectonics yet. But what does this mean? What does this tell you about the ocean floor? So I want you guys to put that together, put your minds together, and I want you to think about that. Together, well, it's kind of a big task, right? That's what a lot of scientists are looking at as separate entities. They're not really pulling it all together as one whole theory. And that's where we enter Harry Hess. And Harry Hess comes up with this concept called seafloor spreading. And basically what he says is that oceanic crust is created at the ridges and destroyed at at the trenches. That's his big theory. Then we have oceanic crust that is created at the ridges and destroyed at the trenches. So we're getting closer to plate tectonics, but we're not quite there yet. And this is all we're really going to, and this is basically it. This is what leads up to the seafloor spreading. So this, again, is coming out of the 1940s through the 1950s. Right? This is where we're really getting a lot of this information. And then we actually are going to get some more information through the 1960s and 70s that leads us to plate tectonics, but we're not quite ready for that yet. Okay, so all we know right now is that our ocean floors have ridges and they have trenches. And the crust is created at the created at the ridge and destroyed at the trenches. That's it. So here's some more examples of that. So as we bubble up at the ridge, we get new crust that is forming, and it basically becomes a big conveyor belt. As that crust is being formed, it's pushing the other crust down and toward the trench. And that process is what we call ridge push. Wrong color. What's going on here? So ridge push and slab pull. Ridge push and slab pull. Where again, at the ridges, we're creating the new crust, and that new crust is basically pushing the other crust down toward the trenches, and then the trenches are actually getting subducted, and that becomes the slab pull, where it's literally being subducted. It's like having your boat leaning too much on the edge of the table. And as too much is over there, eventually the whole thing drags down. Okay, so that's it for our notes.